Okay, so welcome to the big innovation pitch. So the one we're talking about here today is on the interior. It's an initiative which is between BRE and Future Build, and so we've got a few happening across the exhibition today. So really pleased to be here. So the one we're talking about here today is related to interiors. So we know we spend about 90% of our time indoors, so it's really important that we look after the products and materials that we use inside the buildings. And so what we've been looking for through this competition is really to look for innovative solutions that will promote sustainable and healthy interior refurbishment or new build solutions for places where we work and we live. So the process that will take place today is that we're going to have 6 innovators giving us a pitch for 5 minutes, and then afterwards the judges, myself, we ask them questions for exactly 5 minutes. We'll then deliberate for 10 minutes. Please stay around. We'll announce the winner after that.
Hello everyone, my name is Jamie Harbour. I work for a company called Rife Office. This is a deeply surreal experience with the headphones. I feel like I'm in a Daft Punk concert, but it's all lovely to see you. Hello judges. So I want to begin, I feel like 2019 was an awakening in terms of public and business consciousness about the need to address the climate emergency. And this event more broadly is about, and 2020 is not about awakening, it's not about declaring, it's about how we respond. And I think for me, the important thing when thinking about a response is thinking about how we do this strategically and how we can make sure that we're really delivering maximum impact. Now here is an amazing bit of research by Dr. Graham Trelaw. He was head of operational energy. He did a lot of research on operational energy and embodied greenhouse gas emissions in commercial buildings. And what was really surprising and interesting for us is if you look at a 40-year lifespan of a building, 30% of the carbon footprint is furniture. Now, this is because if you're thinking about how we structure and build environments, we build one building, but we cycle furniture in and out every 5 or 6 years. And so you have an enormous amount of furniture going to waste. Every working day in the UK, 300 tons of office furniture goes to landfill. And so actually, when you're thinking about the building, the interior and the designs has a huge, huge impact in terms of the overall life cycle of the building and needs to be taken seriously. And this is what we do at Ripe Office. We deploy the circular economy and remanufacturing to help deliver sustainable, beautiful, and affordable offices. We start with the customer's requirements. We offer a free design service with an award-winning team of interior designers and architects. And then we source furniture. We either source furniture from the client's existing stock or from the second-hand market, of which there's 300 tons going to waste every day. And then we also design our own from sustainable materials. We then remanufacture that waste material. Now that's a quality controlled engineering process in which we break an item down and then remake it to as new, both in terms of appearance and performance. And this leads to an item that's much cheaper with an 80% reduced greenhouse gas footprint. We do this locally in the UK, often with a team of long-term unemployed and disabled people, therefore delivering huge social value benefits and creating a link between a building and a community that's so often neglected in the way that we design and fit our buildings. We transport and install the furniture ourselves, and because we want the furniture back, we don't want it to go to landfill because we know we can remake it over and over again. Every item we sell comes with guaranteed buyback offer. And so, does an item really look and perform the same? Yes, it does. So on the left, you have a new Orange Box G64, which is an ergonomic award-winning chair produced by a leading designer. List price £756. On the right is our alternative, our remanufactured chair. The only difference is we've got the arms the wrong way around because we messed up the photo shoot. But both, apart from that, in terms of both appearance and functionality, it's exactly the same, just with an 80% reduced environmental footprint and 26% of the list price. And this comes on to an important point because normally there is a cost premium associated with sustainability, and that's not necessarily the case with remanufacturing the circular economy. Because we do have a circular business that's vertically integrated and we do it all ourselves. We don't have to pay the distribution margins, which is commonplace in most furniture sales, and our material costs are much lower. And so it means that we can deliver lower cost furniture, which is longer lasting with higher quality, no cost of disposal, great ergonomics for low budget, reduced waste to landfill, and local employment for those who need it. We've also moved beyond just remaking furniture to as new and we make furniture from waste materials. These are tables made from post-consumer waste plastic. The top is a table made from yogurt pots. The bottom is kitchen cutting boards and black bin bags. On the right, you can see a top there with a beautiful remanufactured set of Vitra legs. So our proposition, we've been well received in a number of different sectors, including service, industrials, government, universities. Each of which have different attractions, whether it be the environmental proposition, whether it's the cost savings, or whether it's the social value. But overall, we've seen that over 160 projects have saved clients millions, created beautiful ergonomic offices, saved over 1 million kgs of CO2 avoided, and stopped 300 tons one day of office furniture going to waste. Personally, I'm also most proud of the fact that we provided 6,500 paid hours for local long-term employed people with disabilities. On just one project example here, for a 550 staff office, 94% of the furniture was remanufactured with 8 long-term unemployed and disabled people. And we've delivered a huge range of different projects like this. This was for the UK Green Building Council, the lowest ever carbon fit out. The Child Institute of Waste Management, and a retail space that we did for British Land, remanufacturing furniture from Facebook's old stock. Thank you very much for your time, and together we can build a better, more circular world. Okay.
So, can you? Yeah, you can hear me now. Thank you for the presentation. Great presentation. I guess my question is one about cost. I think you said typically it was about 26% of the cost
of list price.
Of list price. Is that typical for all of your products, or just the one that you showed us?
So in terms of cost savings. Oh, sorry. Yeah. Can everyone hear me? Yeah. So cost savings. There's an interesting in the furniture world, as lots of us know. There's a disproportionately high list price, so that distributors can deliver margins. We typically deliver items that are much less than half a list price if it's remanufactured. If we have to make furniture new, that's not necessarily always cheaper, but compared to a high-end board table, it would be cost saving as well. But if we remanufacture an item, it tends to always be less than half a list price.
Okay, thank you. And my second part of that question is, I think you said you guarantee a buyback, so people don't have to put their furniture to landfill or to waste.
Yeah.
Typically, what's the sort of term that you're seeing people bring the furniture back to you?
Well, it's an interesting question, and at the moment it's theoretical because no one's wanted to give us the furniture back. We've been in existence for 5 years. We haven't had we've had 2.5% of our customer base go away. We have a high rate of retentions, and actually it's a theoretical issue at the moment because we haven't sort of seen it come to fruition yet. But the reality is that every item we sell comes with a buyback clause, so we're expecting to see it again and are planning for it to be put through our remanufacturing process again.
Okay, thank you.
Is this on?
Yeah.
Thanks for your presentation, really interesting. I have 2 questions.
Yeah.
First one, what would be the typical lead time for the furniture? Is that similar to your typical furniture supply, or would there be a longer lead time?
It's actually a shorter lead time because we're not importing furniture internationally. We typically go with a 3 to 4 week lead time, which is quicker than industry standards.
Thanks. And my second question, what's the percentage of recycled content? It probably kind of differs from furniture to furniture, but can you give us a typical overview?
Yeah, so working on the basis of that chair, so all of the parts, the structural parts were reused, and we would resurface, so the backs and the arms, we maybe mechanically polish the base, we reupholster it in fabric. If we get to choose, our preference is 100% recycled materials. So really you're looking at very high reuse content in terms of the furniture we remanufacture. On tables we occasionally would buy a new top, but we would tend to reuse bases. And storage we would reuse as well. So it depends on the item. It's quite difficult to give a generalised answer across all furniture, but I hope that's helpful.
Thanks.
Yeah.
And in terms of the manufacturing process, so you're saying you're employing local people, so how does that kind of a project happens and takes place really?
So we have a distributed form of remanufacturing, and that sounds a little bit pretentious, but what it means in reality is that for large projects we try to set up a workshop on site, and therefore employ a team of long-term unemployed and disabled people from the local area who will train and pay a living wage for the duration of the project. Now that tends to be on a larger project because it's not really fair and or economical to do that on a short-term project. So if we have a sustained period of work for someone who's been out of the workforce or is struggling to get into the workforce, then that's the kind of system that we'll set up. In terms of our own workshop and manufacturing plant, we work with a number of recruitment agencies that try to put people who are furthest from the workforce back into employment.
Very good. And how about the sustainable materials? Where does that? Do you manufacture those yourself?
We work with a range of different sustainable suppliers, and we're always looking to make new contacts, to build partnerships to deliver new, beautiful, sustainable furniture. But it's a combination of stuff that we do in-house and then working with suppliers as well. So it's a combination of the two, and it depends on kind of which item you're specifically speaking about.
Very good. Any more questions?
I think our time is up.
Yeah.
Okay. Thank you very much for listening.
Thank you.
Thank you very much.
Hello, I'm Rafael Diez from Viga, and I'm going to present the patent variable filtration for air conditioning and ventilation systems. More than 100 years enjoying air conditioning, and every part of the HUs have been optimized. But what happens with the filters? They are the same every time, and pollution conditions changes every day and every hour. It's like if you have your accelerator pedal in the same position, no matter if you go uphill or downhill. Many cities in the world have different pollution conditions every time. London, Los Angeles, Hong Kong, Beijing, they have days, very clean days and very productive days, but the filters are always the same. If we had variable filtration, we could guarantee healthy indoor air quality even in the worst days and save energy and maintenance in the clean days. That would be perfect for the three pillars of sustainability: people, economy, and environment. We could improve health and well-being of people, for example, including expensive filters like carbon filters that can stop chemicals that produce respiratory and cardiovascular diseases and even cancer. And we could improve economy using less filtration, the clean days, saving about 5,000 pounds in a building of 1,000 occupants. But overall, we can improve productivity of people about £1 million in the same building of 1,000 occupants. And how can we do that? Well, we have different filters for different target of pollutants, particulates, chemicals, and we can have filters that can be activated or deactivated depending on the outdoor or indoor conditions. For example, in the HUs, we can have regulating dampers just beside the filter. So we can deactivate the filters by opening the damper, and we can activate the filter by closing the damper and make the air go through the filter. We have other many solutions inside the HUs, but we have also solutions outside the HUs. So this is very good for existing buildings or existing installations. And also for the future, we have filters that can move or rotate inside the airflow. We can see another example. This innovation are included in 2 patents of Viga and University of Valladolid and registered as international patents in 2019 and 2020. And the first of the patent have just passed the examination of innovation with 20 of 20 claims declared as innovations. And is this good about business? Well, we have studied hour by hour all the pollutants in a whole year in a typical city like Paris that has similar pollution than London, to know what filters we have to activate and deactivate. And the result is the investment we need is around £7,000, and the energy we save is up to about 2.5 pounds a year in energy, depending on the airflow type and in the air filtration type for particles. That is a return on investment of 2.6 years only of energy. But if we include the maintenance of carbon filters, it would be less than 1.3 years. But if we include the productivity of the people, that as we see before is more than 200 times, more than 200 times the energy saving, it would be a return on investment of an amazing 5 days. And we think this could be a good innovation for companies that want to make a difference with their competitors, providing indoor air quality and saving energy and maintenance in a way never seen before. Thank you very much.
Thank you very much. You got any questions?
Yes. Just a couple of questions to make sure I've understood the product and what it does. So, what is the patent for?
The patent is for we can have air conditioning units that can change the filtration depending of the pollution outside and the condition inside. So we don't need the same filter anymore because our conditions are changing every day and every hour. And we need different filters for different conditions.
So, do you select the filter based on an analysis of the air quality originally? So, whether it's NOx or PM 2.5 or whatever it might be?
Yes. We should measure particulates, PM2.5 or other particulates, and also chemicals, and also ozone or also other chemicals. And depending on what we have, we could activate the filters we need. We could activate HEPA filters, we could activate F9 filters, we can activate carbon filters.
And if you've got variable airflow over the filter, do you incorporate the controls on the off side of the filter to vary the flow in terms of the off condition?
Well, the most complex way would be to have sensors outside and inside.
Okay.
But as many cities like London give you the information for the station, we can take the data from that in a cheapest way.
And does your system include the control technology to control the filter?
Yeah, the patent includes the control.
Okay, thank you.
Thank you.
Yes, just want to double check I understood this correctly. So you have the filters in a row, and depending on the condition, you close off. And do you redirect the airflow, or does it go through all of? How does it work?
Yes, the solution is bypass the filter or make the air go through the filter. If we bypass the filter is deactivated. But if we close the regulating dam, the air goes through the filter. So we can bypass the filter, and it's the way we deactivate it.
So you probably need more space for that.
Yes.
How much more space are we talking about roughly?
Well, the highest space is for the filter. So we only need 1/3 of a space to put the damper and not to make a lot of velocity inside. 1/3.
Okay. And would you then track each filter individually in terms of when it needs to be replaced?
Yes. For the more standard solution, you change the filter the same way than in another HU, because you only have another part just beside the filter, for example, over it, that doesn't give you any problem to change the filter.
Sorry, lots of questions. How many different filters could you put into one AHU?
Well, there is no limit to put one filter after another.
Depending on your space, I assume.
Yes, or depending of the contamination you have in your city.
just one last question for me. So at which stage of the development are you for this technology? Is it a prototype or?
Well, at this moment, it's just a patent we'd like to sell. And it was developed by the University of Valladolid and our company. But in our city, we don't have a lot of pollution. So it's not easy for us to do a prototype that we can measure in this city because it's not a very polluted city.
That's why you're in London.
So London would be a good place.
Thank you very much.
Thank you.
Thank you.
Thank you.
So the third presentation is from Adaptavate.
So about 5 or 6 years ago, I was working as a builder, installing plasterboard and plastering on site. It became increasingly apparent to me that there was a challenge with plasterboard. The price of disposal was significant, it was rising, and secondly, it was harbouring mould and condensation, and this was providing real big challenges with health. Well, after that, I went to go and study a Master's in Sustainable Architecture and developed to the European and American standards a biocomposite material that is a direct alternative to plasterboard. And I'd like to share with you how we are scaling biomaterials for beautiful, healthy and sustainable interiors with our company Adaptavate. Our prime focus is about disrupting material flows in the built environment. How do we do that? Well, we want to move away from finite resources and move towards a more renewable material flow that's more circular so that we can grow renewable capital year on year into high performance, scalable mainstream products. The challenges we are dealing with is associated to gypsum. Gypsum is the main feedstock of plasterboard and it comes from coal-fired power stations and we all know what's happening to them. It's also leading to price increases of wallboard. Secondly, the price of disposal of gypsum, plasterboard is increasing and that's due to it off-gassing a hazardous gas. And thirdly, the important thing for today is it's about the health and well-being of our buildings and really how our building materials can really contribute towards a healthy, sustainable environment. Well, let me introduce to you Breatherboard. Breatherboard is a direct drop-in alternative using my on-site experience, and that was really important. It's used and installed in exactly the same way, but it's got some really interesting benefits. Breatherboard is called Breatherboard because it breathes with the people in the building. It absorbs and desorbs moisture, leading to a healthy, more thermally comfort environment. It has a better thermal and acoustic performance, but it's also grown from natural crops. And it's completely compostable at the end of its life, making it a nutrient to our soils, not a pollutant. We also have a second product on the market, and we'd love to talk to you about any projects that you might have for this, which is Breather Plaster. Launched in the UK and Europe, has all the value propositions of Breatherboard, but yet is really resonating with the design market and the interior market here, a high-end project in the Conduit Club on Mayfair in London. But it's all right having innovative materials, but I set this business up to have an ecological impact. And so what we're doing is challenging the status quo by challenging this vertically integrated heavy industry. With a feedstock pressure in gypsum, this is really fragile. So what we do is scale our business with an asset-light, rapidly scalable, IP-rich business that works with partners in different parts of the world to put the product into that market or territory. And we develop the IP for them to deploy in that area. This brings a real strength from their side and our side into a techno-commercial case that can be deployed in with any partner in any part of the world using locally available bio feedstocks and using locally available workforce. This is giving triple bottom line benefits of social, environmental and economic benefits wherever we put a production facility. If we look at price, Breatherboard is the line in the UK specifically here. If we look at the UK market, Breatherboard price point is on that horizontal line. And we can see 3 different types of wallboard here with standard wallboard at the bottom and performance wallboards at the top. What we can see is that we can enter the market at a price competitive position with performance products right now. And that's about 50% of the market. We are used to specifying performance products. In 5 to 6 years' time, we can be price competitive with standard wallboard. That's unlocking real market opportunity and real health benefits. Our project with the UK Green Building Council, Jamie spoke about it earlier, we were also involved with it. The guys on site said that the product was just like what standard wallboard to use. We've had some real important milestones over the last 5 years, winning a number of entrepreneur and product awards and partnering with some really strong academic and industrial partners, both the BRE, the University of Bath and the BBSRC. And we've built a really good global supply chain network to really scale this innovation. I've also taken my time to really assemble an industry-specific team that has both commercial and technical expertise, but also the industrial process know-how, and the chairman who will guide the business and has experience in scaling global licensed businesses. So I'd invite you to help us scale beautiful, healthy, and sustainable building materials of the future. Thank you.
Do you have any questions?
One question. When you say you are connecting with companies or local companies who are looking to do this in different parts of the world, how does that process work?
Yeah, so if we just go back to this slide here, and it's easier to show. So if we look, it's just got a pointer, yeah. No. So we create we're creating a biocomposite development center that has a demonstration facility and material science lab, and we create IP to be able to license to our partners. We identify partners that have market demands or pressures, some of the things that I was talking about earlier, that are looking for production-led solutions. They're looking for growth opportunities. So we typically identify markets that are attractive, and we look for partners in those markets that are looking for growth opportunities. They typically have a good knowledge of production know-how, and they'll have good access to market. And so we blend our IP and know-how around the industrial process with their access to market to provide a techno-commercial case to be deployed in their territory. So that gives them growth opportunity and us the ability to kind of scale and repeat with other areas in the world. The other thing is that our core technology that we've developed with breather board and breather plaster is also being used into other materials within the built environment that we can deploy our core technology into in time. The first thing is the third most used building material in the world of plasterboard, and then we can use that core know-how to be able to scale into other areas. I hope that answers the question.
Yeah,
super.
thanks.
So, Tom, I think you said that at the moment about 50% of the market is accessible to you from a cost point of view. So, presumably, so this slide, as I interpreted, so 50% is probably below your cost of production and 50% is there or thereabouts. So in terms of the markets that you've gone into, how much market share have you taken out of the sort of 50%?
Yeah, so we are on the verge of, we've signed an agreement with a North American partner, and we're talking to 4 European partners. So we're really at that point of our exclusivity from our North American partners imminent. So I can't stand here and say that we have taken market share to you. Our projections, because we have a performance benefit that resonates with different parts of the market, whether it be acoustic, like weight, health, absorbing VOCs, thermal, it depends on which market you're in. What we can see is just by taking 0.04% of the performance market, the bit that we're overlapping with, we can see that we have a very attractive commercial case. So our business is not predicated on taking 50% of the wallboard market in year 5. Our business case is really around taking small percentages of the performance market, and as you can see, the market projections are such that in 5 or 6 years' time there will be a tipping point whereby our price point can have reduced and plasterboard has increased.
And that was my second question. In terms of the forecast 29 or wherever it tips, is that based on the cost of disposal of the existing product or the cost of both the raw material and disposal? Or?
Yeah, I mean, this is essentially just taking projections from industry, this year's industry projections of between 7 and 8%, and just transposing that into the future. of these products. What we are seeing, which is not really modelled so much here, but we are seeing, because it would be over-egging the pudding a little bit, what we are seeing is that the increases are increasing due to the shortage of the synthetic gypsum from coal-fired power stations. So the market trends are very supportive.
And my last question: what are the things that you see people objecting to prevent your product getting uptaken? Is there anything that you're consistently seeing as an issue? People saying we don't want the product because?
Yeah, we operate in an industry that's resistant to change, right? So what we're doing is we're very clearly communicating performance and health benefits, which people are used to, and the product is installed in the same way. But it is still just about getting in people's minds, and that's why we work with strong partners in territories as well. That's really it.
Okay, thank you.
Yeah.
Do we have time for another question? Okay. Just you were talking about the benefits of your product into the indoor environment. So you're talking about moisture absorptions and VOC absorptions.
Yep.
But what happens if somebody would paint it?
Yeah,
that's what happens quite a lot.
It's a great question. We get it a lot of the time. What about the finishes? Well, the finishes, water emulsion. While the paint industry has got pros and cons to it, right? They've done a good job at cleaning making their paints more breathable. So water-based emulsion is actually quite breathable. What it's not good at is off-gassing some chemicals. But our board and plaster absorbs volatile organic compounds as well and sequesters them. But what you can see is that we do also specify natural and breathable paints for a value-added thing to certain clients. Depends on what driver there is. But pretty much most paints are breathable in terms of their performance.
Great, thank you.
Okay, thank you very much. Thanks.
So now a presentation from Cambon.
So we're a biomaterials platform company. So I'm going to show you the technology we've developed and how it's got a broad range of applications for a number of other products used in construction. So there's a series of problems that we know with modern materials. There are issues about the oil-based resins we use to manufacture them, and then there's also issues around getting rid of the materials at the end of their lives. And what we've tried to develop is a broad-based technology that can attack these problems in a number of different ways. So we're looking at developing resins to disrupt the wood panel industry and also the plastics industry. How can we have a broad-based approach that can improve the sustainability and the environmental credentials of a very, very big series of industries? So then we've used natural-based products from the brewing industry, from bioethanol production, to make the resin that's the basis of all of this. So this is the resin. This is a food-grade feedstock that's 100% plant material. We use this material then to replace urea formaldehyde in making various types of wood panels, and we found that we can also mix it with different types of polymers to have simple, effective bioplastics. This is patented technology with patents granted in China, in Europe and in the United States. So then we have a biomass-based resin with a suite of patents that can replace urea formaldehyde in making things like plywoods, MDF, particle boards. We can use different types of biomass to make molded or pressed products. Importantly, these just replace the resins used in existing manufacturing processes and typically give you manufacturing costs that are 10 to 15% less than the current resins that people are using. So we can use our technology then to give you a platform to make low or no carbon products right through your existing supply chain. As example, we've been working with Foresso. This is a design-led company that makes beautiful indoor panels, but currently uses oil-based resins to make these terrazzo-style materials. We're in effect going to replace those resins that they use to try and give them an environmental upgrade. So there's the challenge: keep the beauty, make the material greener, and integrate with the existing manufacturing process to give them a cheaper manufacturing process, but with an existing product quality and specification. So we're upgrading the manufacturing process to take out the carbon, maintain the aesthetic beauty, and they end up with something that's got less embedded carbon. For a typical panel that's made using our resin, we can take out 40% of the embedded carbon that's in there. There's no VOC or toxic components because we're using a plant-based resin. It's more sustainable because we can make the resin in quantity and that we can lower the production cost. So you have all the green advantages, all the environmental advantages with a reduced cost and the same product benefits. So we're Cambond. We're trying our best to improve materials with lower carbon, make them more sustainable and greener, but without increasing the manufacturing cost. Thank you very much.
Thank you very much. Do you have any questions, Mona?
Thanks very much. One question for me. So it looks like you're using this resin for materials that are manufactured on site. Is there any application you actually use on a building site? Say if you use it to glue flooring or anything in that area?
No, at the moment we're looking at as a drop-in replacement for the resins in existing manufacturing processes.
Okay, brilliant. Thanks.
Thank you.
So in the existing manufacturing, I think you said it takes 10 to 15% of the cost out. Is that for your product on a direct replacement for the alternative?
Yeah.
And do manufacturers typically have to retool, or is the product got the same viscosity?
No,
or?
we've spent some considerable time to make sure it's a simple drop-in replacement. So wherever you would use a resin normally, you swap the resin over, then the mixing, milling and pressing process would be identical. And then you get cost savings in two ways. The resin is slightly cheaper than a urea formaldehyde type resin, significantly cheaper than bioresins or the more expensive urea formaldehyde free resins. Because it doesn't give off toxic chemicals, it means the air handling side of things is much better. The whole safety process of manufacturing is better for your employees and of course for the customers who are living in buildings built with these products.
Well, I was going to ask that question. So do your customers, are they able to charge a premium for the product because it's low VOC, doesn't off-gas in the installation process?
Some might. We're at the business side of things where we are, we know we can't charge a green premium. People want swap the product, but the price has got to be the same. In terms of their marketing side of things, it's an added benefit, if you like, of adopting this technology, in that a number of them think they will charge a green premium.
And is your model to sell the technology to the end customer and they use it in situ to manufacture, or do you sell them the product?
We do several different things. We have a joint venture in China. We're manufacturing up to 10,000 tons a year now, just beginning to enter the market. We sell resin directly to other smaller manufacturers. In Europe, we're looking at a different model where we would license the IP to existing resin manufacturers or distributors, and they can either make it themselves or we can have a joint venture where we'll supply the technology know-how and share that.
And are there any other competing products, or do you have a patent on this and there's nothing else?
We have a patent on this and the use of this plant-based material. There are hundreds of bio-based resins typically they would be from 50 to 300% more than the cost of urea formaldehyde. So we see ourselves as very well positioned from the commercial point of view in terms of cost. Around the world there are some 80 million tonnes of DGGS, the feedstock we use, available. It's a globally traded commodity, so as a business it's eminently scalable.
Okay, thank you.
Okay, do the products that are made with your resin, do they tend to be for aesthetics applications or internal use, or?
People use it whatever you're using the product for. So we made standard plywood, standard MDF, standard OSB. With Foresso, it's a high-end designer-led product that would be, a high-end designer finish for interiors.
And so have you looked into the technical properties of the resin? Do you end up with a product that's got the same performances in terms of moisture resistance and fire?
It would be identical to a standard MDF or a plywood or an OSB made with urea formaldehyde, and those tests have been done. For the products we've made, like dishes and plates using biomass in our resin, that's past FDA and EU food safety standards. So, it's exactly what you'd expect from a food grade resin.
Very good, thank you very much. Any other questions? No? Thank you.
Thank you.
So now we have a presentation from Red Heat.
Okay, good afternoon everyone. My name is David Humphries. I'm the founder and managing director of Red Heat Solutions. Red Heat Solutions, as you can see from the slide here, is a very thin film sheet. It's only measuring about 0.5 millimeter thick. And predominantly it runs on 24 volts of electricity, so it's a low voltage heating system. The exciting aspects of this product is its depth, or its thinness, its utilization in any building, homes, hotels, NHS hospitals, schools. Effectively, it runs on 24 volts of electricity, so it's a low running cost, and it's about half the CO2 emissions of a normal heating system. So the health aspect, so we're basically running on far infrared energy as opposed to convectional heating like radiator systems, so you can eliminate radiators. It works in the same sort of format as underfloor heating, but it can go underfloor, it can also be on walls, and it can also go on ceilings. The benefit to this is its far infrared properties. That's also got health benefits as well. So effectively the body absorbs far infrared energy better than it would with a normal heating convectional system. So you're going to remove air pollution and allergens in the air, and it's a much better form of heating. Regards to its running cost, as you can see here, some tests we've done on a standard wire heating underfloor heating system. It uses about 55% less energy, and its running cost is about 58% less. So we're offering a solution to the market that's going to be as efficient as electric heating, but half the price, which is half the battle. Now, as you can see from the slide here, the main benefit to the product, the cost itself is comparable with wired underfloor heating system, much cheaper than wet when you consider the pipe work, the boiler system you'd have to integrate, or heat pump, whatever the case may be. Installation-wise, it's very, very simple. Being so thin and so durable, both retrofit, it could be a simple case of lifting a floor and relaying this substrate, and laying the floor back on top of it. New build, it could be taken into consideration as part of the build. So we would work with architects at the very, very beginning to integrate this into the product. Annual running cost, if it's hardwired, there is none at all. If it's just simply plug and play with a plug, then it's just standard pat testing. Per square meter, which the sheets are actually a linear meter, it costs about 0.008 pence per hour based on the current unit price of electric of approximately 12 to 13 pence. Warranty, we offer an industry standard 10-year warranty on the sheets, but we expect it to well exceed 25 years. This is a rough case study that we've done, comparing Red Heat to both gas central heating and wide electric underfloor heating. And as you can see, as a broad horizon, it's about 64% in energy reduction. Savings over the last over 3-year period is about £1,000. Energy reduction compared to wired underfloor is about 55%, and savings are huge, about £5,000 over the same 3-year period. This is a very simple process of installation. As you can see by step 1, lifting the floor, relaying our red heat sheets. Once you've relayed them, you wire them into a transformer that converts the 240 volt into 24 volts. We're actually also working at the moment on a product that runs even lower than that as well, but still working on that. So the main benefits of the product effectively is reducing the heating costs and the decarbonisation of heating, in which case it will reduce the fuel poverty, and it's a better solution for tenants, homeowners. The alternative, it also alleviates health conditions. So touch on the health aspects. The main benefits of that is it's like standing in the sun without the UV radiation. So it widens your arteries and capillaries, increases white blood circulation, and it makes you feel more euphoric. Also, the body feels far infrared about 2 to 3 degrees lower than a standard convectional heating system. So it will keep vulnerable people in their homes longer, which is something we're doing at the moment with Swindon Council. And it reduces social care costs, which is a heavy burden on councils across the UK. And it's a better solution for councils, housing and associations. Thank you very much.
Do you want to start with a question?
So, David, is it aimed at the residential market, or do you see it being a commercial offering as well?
At the moment, we're primarily concentrating on the commercial market.
Commercial?
Commercial, correct, yeah. So we're working with clients like Marriott Hotels, Butlins, numerous councils across the UK. We're also sending it to 4 European countries at the moment as well.
And what temperature does it run at?
So the sheets unrestricted will very, very competently get up to about 60, 70 degrees, but keeping in line with the simplicity of the product, it's controlled by a normal wireless or wired thermostat.
So it's typically to replace underfloor heating then?
To replace any heating, yeah. I mean, a lot of questions we get asked is it a supplementary heating or a sole source of heating? This will heat a building, a house, a hotel room, a hospital, a school, in any way, shape or form to the full ability.
What's the output per square metre? What's the thermal
output? Thermal output, it's about 60 to 80 watts per linear metre.
Okay. And in terms of fire risk, presumably this has all been certified?
Yeah, it's all certified under TUV,
yeah.
The European testing standard. It's got electrical certification, fire safety standards. It's also IP45 rated, and we're going to be doing another product soon that's IP60 rated.
So, is your market retrofit or is it new build?
To be honest, initially it was going into retrofit, but we found a lot more in the modular buildings and working with architects at the very beginning. But I would say there's equal both sides, retrofit and new build.
Okay, thank you.
Very much. I think you've basically asked all the questions that I've thought of. Maybe one more question in terms of what you can cover this with. Carpets, floor
tiles,
anything?
Great question. So that's another area that we've obviously had to work very, very hard on. So in actual fact, on top of this product, we could put tile adhesive, carpet, engineered wood flooring, laminate, lino, latex, paint, wallpaper, tiles, anything. We've worked it all.
Brilliant. And can it be regulated, the temperature? How does
Yeah,
that work?
so through a standard wireless thermostat. So effectively, the series from start to finish would be the sheets themselves. They would get powered to a transformer. That transformer would be controlled by mains 240 volt, and that will be then controlled by the thermostat. And if it does go on walls, I can actually drill a hole in that and it will still work fully. Because effectively it's an ink, so its makeup is carbon crystal, graphite and graphene, which are very, very composite products at the moment.
I assume it's pretty instant compared to
very
water-based
instant, yeah.
system,
The transformers are a 96.8% efficient, so a second a current goes through it, you'll feel it instantly.
Yeah. Thanks.
So I've got some questions about the installation. So sorry, I know you put some slides, but do you kind of so how does it work? Do you have to glue it, or how do you fix it to the floor?
It really depends on the substrate you're going to put it on top of. So for instance, if you're putting on walls or ceilings, we've got a perforated version of this product, exactly the same compound mixtures, and we would literally staple it to the wall because you can put holes in it, and you plaster over the top of it, leave it to dry, finished. If it's on flooring, you can go on top of tile adhesive, we can contact adhesive glue it down, we can latex it in, we can chisel it, time consuming, but chisel it into plywood. it depends on the application of the finish of floor.
And in terms of, you talked about the health benefits. So why would that have different health benefits to underfloor heating, for example, if you was put underfloor?
So whether it's a wet underfloor or electrical underfloor heating, the way you heat that room is based on the heat output of that product. So the floor would get up to 45 degrees. That in turn would heat the air, and then from that you would as a human would feel the heat. This is a penetrative, so it's actually heating you as a person and the objects in that room. So it's not wasting energy heating the air around you, albeit everything has a conductivity, so it will also heat the air, but that's not what it's designed for. It's the far infrared, which is the real special benefit of this product. The far infrared being the penetrative heat.
Okay, so just a stupid question. You don't, if you sit on the sofa and you don't actually have any contact with it, it still works.
Yes,
It's just detecting the heat.
Imagine the UV rays of the sun. They're very well absorbent. We emit, and now, as we sit here, we emit far infrared energy. So this replenishes that far infrared energy, and that's where the health aspects come through it.
Okay, thank you.
I have one more question. In relation to maintenance, does it need replacement at any time? If you seal it below your floor or in your wall, does it require replacement?
We've, like most, I've been working on this now for about 3.5 years, and we've not come to the point yet where we've had to replace anything. We may in the future, but if it's set into flooring and it's untampered with, it's very hard to believe what could go wrong with it. And the fact that we can also drop things on top of it, heels can go through it, we can cut whole light switches or plug sockets into it, we can't damage it.
Thanks.
Even with flooding or something like that?
As long as the contacts, the crimps on the end that you can see there with the tails come out, as long as they're not touched, it won't damage. So a lot of the issue that builders have that we've found is if they've got the wired underfloor heating system and someone cuts the wrong place, that's it, the whole floor's knackered. But with this, we don't need that.
Thank you very much.
Thanks.
Thank you.
So our last presentation is from IMA Studio.
Hi everybody. I'll share kind of our project Inhalable Matter, and this is project like a vision of how we can reintroduce nature and bring it back to our built environment. Our studio is Intelligent Morphology and Architecture. It's a small design studio where we investigate different ways how we can integrate biology and design, digital fabrication and computational design. And the initial step, the first step of this project, we were looking in the kind of what is the true nature, how does it work, and what's the difference compared to our built environment. And quite a lot of research showing that all trees in a real forest are connected and they communicate, share nutrition. If one tree is getting sick, or for example a bug's attacking it, it kind of sends these impulses to another tree. So it's a community that kind of we are treating very different now. When we build kind of from concrete, from steel, and bringing the nature kind of, and the same with the green walls, where all plants are disconnected and they don't kind of bring the community together, and they don't function to help us. So the same why do we use plants? We use them to humidify the air, to produce to improve the quality of air. But being in the office where we're spending quite a lot of time, it's quite unpleasant. And how can we kind of think differently about it? And this is our design strategy, where we created quite a lot of kind of a complex system that consists from variety of models. Let's look inside what's kind of there. And there is hydroponics, watering system, and lighting system, and feedback system that we can get the information from. And let's look in each a little bit more detailed, where the water system is looped, and there is a filtering system that kind of pump it, but at the same time, if the system is outside, it could be rainwater that kind of naturally goes in the system. There is the next step is hydroponics, where it could be smaller plants, herbs grown, and bigger plants that's connected between each other, the same like in a true forest with a mycelium, with like a mushroom root or mycorrhizal, like to share kind of and build a healthy life of the plant. That's like in all green walls, it's usually like 2 years. And our system it's unlimited, and we are creating kind of a system of pots that it can stay longer, kind of they have place to grow. And of course, different types of light that needs for humans and needs to like for plants, because we mainly now targeting interior kind of spaces. And currently, few prototypes built. We're testing how the plants are reacting when they're all connected. Is it different? How's the watering system? And each plant gets a different amount of water with dripping system. Also, we're experimenting quite a lot with different materials and design solutions to looking more sustainable and local materials. And kind of, and in terms of implementation, so what are we getting? Like we're getting like a clean air with like a natural design solution, humidity, and like indirect changes would be that people in the greener areas are first of all much more productive and at the same time getting much less antidepressants. That kind of like looks like a simple thing, but not a lot of us have like enough time to go for like a countryside or like there. And because it's a parametric model, it's quite easy to adjust different types of models for depends on the space according to amount of people are there, like square meters, and kind of aggregated in a variety of options. So it's more like a design system. At the same time, if we compare it to humidifiers that people use, or green walls, that green walls is just a vertical solution. And at the same time, it's much easier to update your iPhone than to update kind of concrete kind of building that we're really missing now. That's kind of envelopes that can improve the quality of the building. And the budget is quite low for like but we also always try to get it down. Depends on the models and it depends on the cost. But all materials can be sourced locally. And kind of to end up with a kind of more like a vision thing. That can you imagine if you work like in a big office and you have a space that's completely isolated and you can enter it and just be in the green space for like 30 minutes a day? Would it change kind of? And at the same time, it's produce air for the whole area, and it's kind of can be implemented in any office. And I mean, in the future, we're going for more like square spaces and community work. But for now, interior is our. Yep. Thank you.
Yes, thanks very much. Just wanted to ask in a little bit more detail. So, what would be the difference to, say, the green wall behind you? You're talking about looking at it. Is it the maintenance that reduced, or you're talking about the 3D element? But are there any other differences?
I mean, I would say like two main. One is that in this green wall, 2 years is the maximum. Usually it's 1 year and all plants has to be replaced. So it's mostly disposable plants that we think kind of you need to be a little bit more conscious about this. So we're more trying to build an ecosystem in this kind of synthetic environment that can be functional, like potentially growing and kind of in longer terms. At the same time, it's special configuration because not in every space you want this wall kind of, but can you start creating like more design solution spaces? Also, it's a modular system, so you can start from a smaller one and then keep growing kind of bigger one, or like have a particular separation kind of. There are quite a lot of variations for it.
Thanks. I have one more question. You were showing the cost for the 6,600 pounds. It was a bit too quick. What was the cost for? Is it
for 10 models around this? So 10 models will be. Let's look back. Oh. No. But it was like a diagram. So one model is hexagon. So it will be kind of big hexagons and like kind of quite a few inside.
And what's the, do you know the price comparison to, say, a standard wall-mounted green wall?
It's quite similar. It's a little bit more expensive, but at the same time, in the lifespan, they're like much, like getting much cheaper.
Okay, thanks.
In the presentation, you showed some indoor environmental quality benefits in terms of CO2, TVOC, and so on. Is that data come from installations you've actually tested? Because it looks different to data I've seen about the impact of plants and indoor environment elsewhere.
I mean, partly I think we'd mainly collected the data, so I wonder why it's like different. But some we tested on like a smaller units.
So just explain to me how you've done that. So you've put plants into a space and measured the reduction in CO2 and TVOCs?
Yeah, like mainly in the cube kind of smaller environments.
Okay.
But most of the data we collected, so it's not like I like wonder why did you see like a different one?
Oh, it's just
Like
I've been when I've looked for plants that actually impact indoor environment, it's surprising how small an impact they actually make. Has been my experience. So just wondering, so which type of plants have you used?
We use different because like for hydroponics we're using more like herbs and stuff, but like it's all interior plants. For example, in our prototypes, it's the ones that can survive in like darker kind of more areas because the prototype was an exhibition where it was like not the best environment. So we kind of try to look what's where it's gonna be. Like so, but mainly interior plants.
So if you were to summarise the main advantage of your offering or your solution, what would it be?
It will be like a special configuration that we can create like those spaces where we really hope to build a space where people can experience nature inside this city, even if it's like very different.
Okay.
It can be outside, inside, but kind of creating the envelope for existing and updating existing buildings.
And you see it as both external and internal?
Yes. Now we're more focused on interior, but like external like will be like more with water kind of collected, rainwater, like and kind of less electronics and feedback, because we're collecting also bio-impulses and about like how plants feel inside. But this will be simplified, and that's why I would say like if we can implement also community work, that it's like older people or something, like kind of get more like to square areas. But also like when it's like London is quite a green city compared to like if you look on like Hong Kong or like New York. But like if it will go around skyscrapers and kind of start building these green vertical spaces.
And is your concept it's temporary and mobile, or is it permanent, or a combination of both?
It's easy to disassemble and move it, so it just like because the models are very simple now, they just curved from like one straight line, kind of bended, and they can be disassembled on 3 types of models and reassembled. Like one model, it's around 20 minutes, so it will go quite fast.
Okay, thank you.
Thank you. And just one last question. I was just interested because in one of the slides that you showed at the beginning, you were showing some lights and some sensors. Is that the aim that your system should be providing this kind of?
I would say we like in the beginning and this research because we have we collected some bio-impulses, but still there are no quite enough data. What does it say? But at the same time, like kind of getting to the roots and see like is it enough water, like and kind of collecting everything and getting feedback on the facade of the system and getting it on your app, and also for example for people to know what the system is showing to them, and if there is like a communication kind of what's going on, like which plants are sick and maybe we need to change the kind of amount of water for them. Like.
Thank you very much.
Yep, thank you.
So this was our last pitch for today. So if you can stay. Yeah, if you can stay here for the next 10 minutes, and we'll have a discussion and decide which innovation to give the award to. So thank you very much. Right, thank you very much. Can you hear me? Yeah? So first, I'd like to thank all the organisation that came today and gave a great presentation. So it was really interesting, some amazing range of different innovations, and really enjoyed listening to all that. So it was quite a difficult decision actually to make. I think you brought in some very different angles, different innovations, and very interesting. But we had to pick a winner, so we decided to go with Ripe Office. So thank you very much. Well done. And the reason is because we thought in terms of environmental impact, it was really interesting. We also like the social aspects that you brought into the business, and the kind of the long-term circularity angles that you're looking into your product. So congratulations, and all the best for the future.